Okay, this is round 2 of this audio here. The first time it did not work, so I'm going to do a quick run through. If I have time to do a smaller one, I will, but first of all, kind of looking through our vocabulary here. Couple key things. Measure of average kinetic energy is temperature. Energy transferred between objects that are different temperatures, heat or thermal energy is the type of energy. I know that you know a thermometer is the device we use. The lowest possible temperature, where there would be no kinetic energy, is going to be absolute zero, no movement. Method of energy transfer that takes place when two objects are in direct contact is conduction. Method of energy transfer that involves movement of matter, so like convection currents, warm rising, cool sinking, convection currents. Method of energy transfer that is electromagnetic waves, that would be radiation because it can transfer through outer space. Okay, it is recording. It's being weird. And then we've got any material through which energy can be easily transferred as heat is a conductor. Poor conductors are often insulators. And then the definition of specific heat, the amount of energy required to raise 1 kilogram of that substance by 1 Kelvin. Difference between heat and temperature, those are just in the definitions above. Temperature, how fast molecules are moving. Heat, the transfer of thermal energy between two objects at different temperatures. When the kinetic energy goes up, we're on 12 and 13 here, the energy of the particles increases. When the kinetic energy decreases, it decreases. Remember, as that energy and the particles start moving faster and faster, they spread out more. So hotter things become less dense. Heat energy always flows from higher kinetic energy to lower. So from hotter objects to cooler objects. In general, what types of substances take a small amount of energy? Those are conductors. Ones that need a lot of energy to change their temperature are insulators. 17, hot air or water will rise, while cool air or water will sink, like convection currents. It's less dense. You know, write that. During a phase change, what happens to the temperature of a substance? Remember, it stays the same. As we go through our phase change, it increases. Oh, we're changing phases, so it's going to stay the same when it changes. And then, so solid, liquid, gas, when we talked about those earlier. What type of energy exists in the random motion and vibrations of atoms and molecules? Kinetic energy, energy of motion. Looking at this heat transfer. On this one, this is showing warm rising and cool sinking. Red is warm, blue is cool. So this would be the hot water or liquid or whatever is there rising because it's less dense. The cold is sinking. So this is convection currents being shown. The next one is from your gizmo. If you notice, it's a hollow tube here. And so these two are going to mix and make green. And because this one's warmer, they will eventually both be 35 degrees. But it's asking, how would it be different if the temperature on the bottom were 20 and the top is 50? Well, remember, since warm will rise, if this is where the warmer one is, it's going to rise here. So it's still going to mix. It will just take longer because you've got the warmer liquid on top. If this were solid and not hollow where they could mix, then it would become conduction because they couldn't mix. It would have to just transfer through the copper solid pipe. Down here, we're converting between different temperature scales. The first one is going from 55 on the Fahrenheit to Kelvin. Remember, you have to take 2 steps. You have to go from Fahrenheit to Celsius to Kelvin. You cannot go directly from Fahrenheit to Kelvin. So, this is our formula. Fahrenheit minus 32 divided by 1.8 gives you 128 degrees Celsius. To change it to kelvins, you add 273. So this is step 1, step 2. Converting 300 Kelvin to Celsius, you just subtract. So starting in Kelvin, going to Celsius, you just subtract. 27 degrees as your answer. These are our answers. The next one is converting from 458 Kelvin to Fahrenheit. Again, you have to go to Celsius first. So Kelvin to Celsius minus 273, which gives you 185 degrees Celsius. And then converting it to Fahrenheit, that is 1.8 times Celsius. So 1.8 times 185 plus 32 gives you 365 degrees Fahrenheit. Okay, next we're looking at specific heat. Definition we already talked about. The amount of energy needed to raise 1 kilogram of a substance 1 degrees Celsius or Kelvin. Based on their specific heats, which substance allows for heat transfer most easily? So remember, most easily is going to have the lowest specific heat. So that's silver, and those are conductors. Which substance does not allow for heat transfer easily? That would be a high specific heat, meaning it takes a lot of energy to heat it up, and that would be water, and those are insulators. Using the chart, which substance can transfer heat and electricity better, aluminum or iron? Iron, because it's got a lower specific heat. If you look up here, iron is 450, aluminum is 920. And then which substance does not easily transfer heat and electricity? Sand or carbon? Carbon is 710, sand is 664. So it would be carbon because it has a high specific heat. This is from our gizmo. If you apply 10 joules of heat energy to 1 gram of water and 10 joules of heat energy to 1 gram of iron, so we're comparing iron and water, will they each experience a 1 degree increase in temperature? No, because they have different specific heats. So water probably would not heat up as much as iron because it has a high specific heat. Imagine you have 10 grams of carbon at 100 degrees and 10 grams of copper at 100. So we're looking at carbon and copper. Which substance will maintain its temperature longer? That's carbon. It has a higher specific heat. It's more of an insulator. I received a new silver necklace for my birthday because fake metal jewelry makes me break out in hives. I tested the characteristic property of specific heat in the necklace. I found that the specific heat was 920 joules per kilogram Kelvin. Was my necklace real silver? So if we look at our chart, 920 in silver, nope. Silver is 235, but aluminum is 920. So necklace is probably made out of aluminum. Okay, next, specific heat problems. Remember, this is our amount. Q is the amount of heat energy gained or lost. C is specific heat. M is mass. Delta T is change in temperature. So here's our triangle with Q, M, C, and delta T. 30, how much thermal energy will cause a temperature of 17 kilograms of iron with a specific heat of 450 to increase its temperature from 15 kelvins to 60. So this is our formula. Q is 17 grams is our mass, 450 is our specific heat, and our change in temperature is 60 minus 15 or 45. Multiply it together. 31. How much thermal energy must a refrigerator absorb from 225 grams of water so the temperature will drop from 35 to 5 degrees Celsius? Specific heat of water, 4.18 joules per gram degrees Celsius. Both of these are in grams, so we don't have to convert it since they're both there. I will not make you convert anything like that on the test. So again, Q equals our mass times our specific heat times our change in temperature, 35 to 5 or 30 degrees. I did have some people, since it was final minus initial, have this be negative 30, which give you a negative energy. Don't worry about that, but you will not have a negative energy. So get rid of the negative on that. 32. How much thermal energy is needed to increase the temperature of 755 grams of iron from 283 to 403 degrees Celsius? Specific heat is 0.45. So again, Q, our mass, our specific heat, and our change in temperature, which is 403 minus 283, which is 120. 40,770 joules. Challenge. If the temperature of a substance increases by 13 kelvins when 935 joules is added to a 7 kilogram quantity, what is the specific heat? So now we're looking a little bit different. If we go back up to our formula, we're looking for C. So that's Q divided by M times delta T right here. So our Q, our mass, our delta T. And make sure you keep these in parentheses for order of operations to get 10.2 joules per kilogram degrees Celsius. Kelvins. And then finally, 34, use the differences between a conductor and an insulator and the concept of specific heat to explain whether you would rather drink a hot beverage from not form, a metal cup or from a styrofoam. Well, a metal cup, if it gets hot real easily, is going to burn your mouth. So I would say styrofoam because it's an insulator and won't get hot and burn your mouth. Okay, that is all.